Hi there, I'm SR Coder, and this is the second video in my new MLAPI series of videos. In this video, we're going to create some UI, so we're going to replace the standard Network Manager UI and with our own buttons. The buttons will allow us to host or join a game. We're also going to do some authentication, where we're going to check the incoming connections are valid and they're trying to connect to the correct game. And we're also going to do a very, very simple spawn system where you can spawn in at a random position and the server spawns the connected clients in at the random position too. So it'll be a little bit like this, where you click the host, the buttons disappear, and when a secondary connection comes in, you'll be able to, the connection will come in at a new random position. I'm just loading that up on my other screen right now and click and join. And you see it comes up in here. So yeah, that's the video. Stick with it and hope you enjoy it. Let's get started with this UI. So all I'm going to do is I'm going to create this UI with a simple couple of buttons. So I'll just add this first button in here. So I'm going to call this connection UI, because that's what it's going to do. And I'm going to start with this first button here. I'm just going to call this a host button. So what we want to do is just make this run the simple host button that you see when you've got this network manager. We've got this start host button, and then we will also need our client button as well. So we've got this connection UI, we've got this host button. Just going to go into 2D and double click the whole thing so I can see where things are. So this host button here, oh yeah, before I do that, I'm just going to make sure that the canvas is set to scale with screen size. You'll see that makes a difference. The button shoots off in the wrong direction, so I'm just going to drag this button up to the left hand side and change the text of that to host. And we'll leave that as it is. And then this host button, we're going to Control D to duplicate and rename that to the join button. And that's where we're going to just be able to join as a client. So we've got this join button, just move it across to the other side. With you're using UI, you probably already know this, but the buttons, we need to set their anchor points to the nearest corner or place within it. So I'm just going to do that for both of these. So set the anchor point. That way when I scale the screen size, they're not going to go mental. And this join button, obviously I need to change the text to join. I'm going to change this later on in one of the later tutorials, so we've got an IP address that we can type in. But right now we're just going to join local and just get it working nice and simple. All right, we're going to write our first piece of code. So let's create a new C# script. We're going to call this connection manager. And when this is all loaded up, we're just going to add this connection manager to the connection UI object. It could be its own game object, its own empty game object, but it doesn't really matter. For now, we'll just put it on this connection UI canvas. I'm just going to drag and drop that on, and then we're just going to open up Visual Studio and get started with the code. For this, we're just going to keep it really simple. All we're going to do is we're going to add this using MLAPI. So that we've got access to the network manager singleton. We don't actually need to make this a network behavior, so we can leave this as a mono behavior right now, and we're going to get rid of the start and the update just to begin with. What we're going to write is our own public variables, public functions, in order to use the buttons that we're going to run when we do the buttons. So we're going to make the first one, which is called host, and we're going to just access the MLAPI network manager. So if you type in network manager, because we've included this MLAPI, we'll have access to the network manager singleton. And then from there, we can just host the button. So we can say start host. And that just is as simple as it gets. Now we'll hook up the button before I forget. So if we jump back into our project and go to this host button when this finally loads up. Once we've got this host button there, we add the event, and because we put it on the connection UI, we're just going to drag the connection UI game object on there, find the connection manager class, and then we've got the host button that's already hooked up to that. So when we click host, we should join straight to host. So just make sure that that actually works. If we're able to hit play right now and click host, we've already started the game. For the other button, it's pretty much exactly the same. All we need to do is make another public method. So we'll just do public void, and I called the button join, so we may as well call the method join. And then we do, oops, I hate when it does that. We do the open brackets, close brackets, and enter. So again, it's the same thing. We just do network manager.singleton, and then there's actually a start client method. But these are just blank, and we'll hook both of them up so that they work. So we're basically replacing the built-in UI that is visible within the MLAPI network manager right now. So the join button is the one I want to hook up. So I'm going to click plus. Again, we've got the connection UI, drag that on, and for the class, we're looking for the connection manager, and we're looking for the join button. So in theory, we're going to make sure that this is all saved. I can open up my other instance and we'll just test that and make sure that it actually works. So I've got both instances up and running here, and you'll see that once this is up and running, if I hit host on this one, we get the cube appear, and on the other instance I'll hit join, and you'll see that both cubes are on both of the instances. So we've got that connected, and we've basically, all we've really done is changed the UI so that we've got some control over this, and that provides us the opportunity to open up to creating our own spawn points, spawning in different prefabs, and also the authentication that I'm going to go on to next. The authentication that I mentioned, the connection approval here, is I just kind of like simplify this from the MLAPI documentation from the Unity multiplayer networking page. You can see the connection approval. It's not difficult. It's not a whole lot of line, but it can be simplified again. But basically, you're just creating a delegate here, and you're assigning this approval check to the to be run when the server tries to connect. It does say here that it's a server only example, so this does run on the server when someone else tries to connect to this. So just keep that in mind, and we'll just go ahead and encode some of this. So in order for it to work, we need using MLAPI.spawning. And all we're going to do is inside this host, this is where sort of some of the magic happens. So this is where we're going to create this this connection with this callback. So we're just going to say the network manager dot singleton. So we're going to get this singleton, and we're going to say that the connection approval callback here is we're going to assign this approval check function that we haven't written yet to it. So if you just write approval check and then save this, you'll see if you hover over it, it doesn't know what it is. So we'll get this to auto generate. So we're just going to generate that method, and it happens directly under. And both those things happen on the server. So happen on server, and copy that, paste that in here. So this happens on the server as well. From the documentation, you'll see these are distinctly unhelpful. The first parameter, and if you just, again, I just relate you back to this, but the first parameter is the actual connection data. So if I just highlight that and we just go, this will make it easier to identify. So the first parameter is the connection data. The second parameter is the actual client ID. We'll just call it client ID. And the last one is the delegate that we're going to run inside here. So we're just going to call this just what Unity does. We're going to call it callback, and we can get rid of this. We can actually reduce what we saw in the Unity version into just one line. When you do this callback method, you'll see that it highlights all of the different things that we need. We actually make this really simple and just get it to work first up. So bool create player object, that means we want to create the player object, so we'll call that one true. The player prefab hash, we can actually just leave that as null, and it'll use the default one because we ticked ours as the default player prefab. This is where you'd obviously be able to choose a different one, so you could spawn in like red team or blue team based on some other conditions. And the last thing is approved, and because we're not checking right now, we will do that in a second, but we'll just say true, it is approved. And then we can set the position and the rotation of the actual spawn. And just so that we can get this working and keep it as simple as possible, we'll just say vector 3.0 and quaternion.identity. So that'll just like the zeros for all of it. You'll notice that also in the host button here, the start host, we can actually do the same thing there as well. So we can, the start host can take in the actual position as well. So just because it will make it simpler, I will say vector 3.0 and quaternion.identity. We are actually going to move on and create a random value for these, or use a spawn manager. So just these lines on its own are enough to create this approval check, and we want to see what happens. So let's just do a quick debug.log in here, and we're just going to say approving a connection. Hopefully we should see that come up on the server or the host machine when somebody else tries to connect. So make sure that that's all done, and then we'll just test that, make sure it works. The last step you need to make in order to make sure that the network manager, just before we test it, the network manager is has the connection approval enabled, is to make sure that it is enabled in the network manager. So highlight the network manager and go down to where it says connection, and there's connection approval. So this will force the network manager to look for and run that function, so that we actually force it to check for connection approval before we just automatically connect anyone. Imagine you're like me and you're teaching game development, and you've got 5 or 6 different games going on. You want to make sure that it's actually the right game that you're trying to connect to. So we'll just test this to make sure that it works. So you see it in action here. We've got the one game running on this side, and I've just started that as a host, and you see nothing comes up just yet, as you'd expect. And on this right hand side, this game's running. If I click join, you'll see that the connection approval runs on the server, which happened to be this one here, and it said approving a connection. So this one was approved and joined the game. You can see again, both these cubes are in here. So how do we actually make sure that we have the right connection, or that the client trying to connect is actually approved? What we need to do basically is when we join, is we want to set some sort of password in the connection data. The way you do that is actually by encoding it. By encoding it, it allows it to be encrypted. So it seems like a long-winded thing, but it actually makes things a lot more secure and safer than a lot of the previous solutions. So the bottom line is I need to actually, when I'm starting the client, I need to actually set the connection data. And if you follow along with this, it's just network manager.singleton. So we're going to go to network manager.singleton, and we're going to find the network config. Here we go. So network config.connection data. And we're going to, there it is, the connection data. And we're going to set it to some sort of text value. Now, again, I did mention it's kind of confusing, but if we just do system.text.encoding, not encoder, but encoding.ascii. So we encode some text to ASCII, and we need to do the actual bytes, because we need an actual byte array. You can see that it sets it as a byte array that we need to pass. So we'll just say get bytes, and then we'll pass in some strings. So I'm just going to use some amazingly secure thing like password 1234, because no one's ever seen that before. So what that does is it encodes this password 123 as a byte array using this system.text.encoding.ascii, and sticks it into the connection data. So when that's done, when you start the client, what the client's going to do is it's going to have that data, and it's that data that we're going to check when we do this approval check. You see that the connection data is passed to the approval check. So what we need to do is, rather than this debug.log, what we're going to do is, I'm just going to give myself a comment. So check the incoming data is is what I'm looking to do. So there's a couple of ways of doing it. I'm just going to, probably the easiest thing is just to go straight to it. So I'm going to create an approve variable, which will be a bool, a true or a false. And I'm going to set that equal to the comparison between the incoming data and the actual password. So this will probably become clearer when I've done it, but we're just going to do the decoding version of it. So I'm going to say encoding dot ASCII again dot get string this time, and this gets a string from a byte array. It's like the complete opposite. You'll see that I've got this this function here that does the opposite of the function that we saw when we encoded it. So we'll pass the connection data in here. So the this will get what that connection data is, and we'll just compare it to the password that we put in. So password 1234 was what we put in. So what you've ended up with is, if this is equal to the result of all of this, then we'll obviously get a true, and so approve will be true. If when we decode the connection data and it's not equal to password 1234, then approve will end up being false. And it's rather elegant, but it may be a little bit difficult to understand exactly what's going on. So in the callback, you'll see that one of these parameters was whether it was approved or not, and I believe it was the last one. We can find out by just going, if we open up the brackets, we should be able to see the help again. So it was the third parameter was the approved value. So instead of the word true, where we're just confirming it, we'll just put in approve. So if it's not approved, then it will not work, and it will not connect, which is basically fairly simple. So hopefully that makes sense, and we're just going to quickly test that, make sure that it still actually works. So as you can see, everything still works. I click the host and you're able to host, and your test cube gets joined in. I click the join and it goes through the connection approval process, and we get that second cube in. Now, if you really wanted to test it thoroughly, what you could do is just go to the code, and when you click the join button, obviously this is done on a client, on a connected client. That's the whole point. If you change this password and got it wrong, so this is, for example, maybe a different game or a different version of this game that you'd shared with people. If this was different, if this was wrong, then obviously you the approval would end up as false and it just wouldn't join. So you could click the button all day and it just wouldn't join. So if you really want to be thorough, you can test that just to make sure that that is actually the case. So the connected client has to have the right version of the game, and it has to include this password. So I mean, you can use this as like a version check. So if you're shared your multiplayer game with people and you want to join, but you've made changes to it, they would be able to connect anyway if you didn't change this password, so that they're ensuring that they're connecting to exactly the right version of your game, so that you don't get any weird stuff happening, like they're clipping through walls and stuff. All right, and just as the last little bonus, why don't we get it to spawn at a random position? And obviously we've just said to spawn it at 0, but it would be much nicer if we could spawn it at random positions. And because when we click on the host here, the approval check is done on the server, as I mentioned before. So what we do when we actually run this callback that goes and runs on the client, this actually happens on the server. So the connecting client will be given the spawn point that they are wanting to spawn at. So we can actually do that here. So I'll just make a real quick function, and that will allow us to choose this random position. So it's just going to be void. I'll call it get random spawn. If I can spell. And it doesn't need to take any parameters at all. And what I'm going to do is just going to say I'm going to get a random value. So random dot range. If that doesn't come up for you, it may be that you've included using system. There's actually a system version. So if you've got using system here, just get rid of that so that you definitely are able to get the Unity version of random.range. and this takes some values, a minimum and a maximum. And if I just say -10 and +10 as the minimum and maximum, and rather than type this all out again, I'm just going to paste it 2 more times and make this one a Y and this one a Z, and then we should be able to return a new vector3, which is made up of the X, the Y, and the Z, and hopefully that'll be, you know, like a random value between -10 and 10. Sorry, it's not a void return type because we're actually returning the vector3, so it's a vector3 return type. So there we go. So I was doing it wrong. So when we join, this is going to run on the server, clearly. When we host, this is going to run on the server. So what we want to do is, instead of this vector3.0, we're just going to get the random spawn, use that instead. And in this location here, when the server approves an incoming client or an incoming client connection, we can use this value here to spawn in at a specific location. So we'll just use get random spawn. So it's a pretty simple function. I'm just going to call it here and here, and obviously in the next video or later videos I might actually do a slightly more useful version of that, so that we're able to have specific spawn points rather than just randomly selected spawn points. I'm just going to test this, make sure that it works. So I'm going to run both the host and the client, as you can see here, just to test that it works. So you can see from this, when we run the host on one side, it's given a random spawn position. I can barely see it off of here. And when we join on the other side, we're given a different spawn position. If I just go to the scene view, you'll see, if I double click this one, not in 2D, there we go. So you see we've got 2 different positions, and it should be, will be exactly the same on the connected client as well, because it's all done on the server, so it's told where it's going to spawn. The thing that I don't like, that we're just going to quickly fix, is that the buttons don't disappear. So let's just fix that. In order for the buttons to disappear, probably the easiest thing to do is, if we're, let's make this big for now, if we add a panel to put buttons on, then we can disable the panel and keep this canvas. So on top of this, we're just going to right click, say UI, and then panel, and the panel acts like a top level game object, like an empty game object. It actually puts a little sort of slightly see-through image. So we'll call this connect button panel or something like that. And because it's already set to stretch, back to 2D again so we can see this. So the connect button panel, it just covers the whole screen because I had my screen shrunk. It ended up doing that. But the buttons we just drag, select, just do that. So close them all down. So select both of them with the control and just drag them onto the connect button panel, and everything should stay pretty much exactly as it was. This connect button panel we want to switch off inside of our UI when we actually click the host or the join. You're effectively just doing this in code, and because the buttons are a child of the panel, they'll disappear too, and you'll not be able to use them. So if we jump to our code, we'll need a reference to that panel. So I'll just make it public for now, public game object, and we'll call it connection button panel. And when we host, this is when we actually host the button, click the host button, and just before we start the host, this is when we're going to assume that everything's going to go to plan. We're going to switch this off. So we'll just say connection button panel dot enabled, set active false. And we can copy this line again. And when we click on the join button, we assume that we'll want to start the client. So we'll assume that everything has worked correctly, and we'll get rid of it now, right there. So this is done on the client that connects. So once again, just make sure that that works, and we'll give it a quick test. So just like me, don't forget that you need to actually assign that now. So the connection UI, the actual panel now needs to be dragged onto that connection button so that it disables. And then when you run that, what you should be able to do is, this is just running over here, you should be able to click the host button and you'll see that the buttons actually disappear. So hopefully that's been fairly easy to follow. We've done a fair amount in this tutorial. We've managed to add in some custom UI. We've managed to hook those buttons up so that we can join as a host or we can join as a client. And we've managed to do some fairly simple approval checks so that we make sure that the incoming connection is actually trying to connect to the correct game. We obviously want it to be the right game, or it could be a bit of a disaster. We've also done a very, very simple spawn system where we're spawning at random positions rather than always in the middle. So hopefully that's been pretty clear, and stay tuned for the next video in the series.